All right, so when you walk into class, after having finished notes 6.11 and 6.81, you walk into class tomorrow, you might be able to fill out the things that you see here. I'll be prompting you with this slide, and it says formula that relates fraction of a circle to distance, and you might be able to remember what that is and write it down. Pi radians is equal to, you might be able to remember what that is and write it down. And then you might also be able to look at these and fill in these tick marks. Because you've done assignment 6A1, you might even be able to do some of these by memory, and then you'll have to figure some of the rest of them out. In any case, this is what it looks like. I hope you can remember that this is where 0 is, and you go all the way to pi, and then all the way back to 2 pi again. Halfway from 0 to pi is pi over 2. And then another thing to remember is that each of these tick marks over here represents 1/8 of a circle, or a quarter pi. So 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi. And if you simplify this fraction, then that's what you get. You can either figure them out or have them memorized. I think the more you can have memorized, the stronger you're going to be. And then you can figure out whichever ones you don't exactly remember. Same thing here. This is organized like a clock. So 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi, 5/6 pi, 6/6 pi, 7/6 pi, 8/6 pi, 9/6 pi, 10/6 pi, 11/6 pi, 12/6 pi, and then the fractions simplify. The more you can have memorized, the better. It's kind of like your multiplication tables. If a teacher asks you what is 6 times 7, you've got two options. You can either remember it as 42, and that helps you with higher other things that require you to, like solving equations and stuff like that. If you had to figure out on your hands and fingers how to calculate 6 times 7, it would take you a while, and you could do it. Same thing here. These are eventually going to become basic skills that you're going to build on top of. So the more you can have memorized, the more fluid, the more advanced sections are going to be. So let's go straight on to the notes. 6.12, this is new stuff. The unit circle, day 2. So I just want to refresh you from geometry, something that you might have done with your geometry teacher. 45, 45, 90 triangles and 30, 60, 90 triangles. It's not going to look exactly the way you did it in geometry, but this is the way, these are the same ideas here. So 45, 45, 90 triangle is an isosceles triangle. This leg and this leg are going to be the same length, so you can give them the same variable, x and x. Using the Pythagorean Theorem, and then the hypotenuse, I'm just going to assume that the hypotenuse is 1, because we're dealing with unit circles, and all these hypotenuses and all these radii, they're all going to be 1 because it's a unit circle. If we say that this is 1 and we don't know what this is here, we can say that Pythagorean Theorem says a squared plus b squared equals c squared, or x squared plus x squared equals 1 squared. Combining like terms and dividing by 2, taking the square root of both sides, you get x is equal to plus or minus the square root of 1/2. Now, it's a geometric triangle, so there's no way that this is going to be a negative length. So we'll just take it as the positive square root of 1/2, which simplifies to this. And then if you want to rationalize the denominator, you can't keep square roots in the denominator. You multiply it by a form of 1, and you get this here. Square root of 2 times square root of 2 is 2. So this is a big deal fraction that you're going to see for the next several videos. Like for the rest of the chapter, pretty much this fraction is going to come up over and over again. Anytime you see 45, 45, 90 triangles, this square root of 2 over 2 is just going to show its face over and over again. It's approximately equal to 0.707, like if you actually type it into a calculator. And sometimes I'll be writing 0.707 or 0.71, and sometimes I'll be writing the square root of 2 over 2. And it's just really important to associate this 45 degrees with square root of 2 over 2. That's actually what the length is. If this has a length of 1, then this has a length of 0.707 right here, 0.707. Similarly, you could start off with an equilateral triangle, like 60, 60, 60, and then you can cut it in half, 60 to make a 30, 60, 90 triangle. When you cut that in half, this length becomes 1/2, because this over here was 1. Remember, this is going to fit on a unit circle, so all the hypotenuses are going to be have a length of 1. So we know that this is 1/2. We know this is 1. The only thing we don't know is what this is. It's x. So we'll call it x. It's different from the previous x. And so Pythagorean Theorem says that x squared, a squared plus b squared equals c squared, or x squared plus 1/2 squared is equal to 1 squared. When you solve this equation, you eventually get x is equal to the plus or minus the square root of 3/4. Now, we're not going to take the negative because it's a geometric length, and so therefore, and the square root of 4 in the denominator just becomes 2. This square root of 3/2 is just going to come up over and over and over and over again. Anytime you see 30, 60, 90 triangles, you can associate 1/2 and square root of 3/2 to be the length that we'll need. And if you want a decimal, it's about 0.866. And sometimes I even just write 0.87. That's a round. So with those facts in mind, we can start to label even more points. Now, we can start to label points. This UV axis right here, we know that this is the U axis and this is the V axis. And so this point right here is the point 1, 0. Remember, it's a unit circle, so this radius right here goes you from the center 1 unit over. 1 unit up, 1 unit to the left, 1 unit down. And so these are the coordinate points that we can have. Just the idea of coordinate points is a little different from the previous section, or a little new. But anyway, we can always find these coordinate points. And so these are going to be more things that are going to be good to be able to figure out, or even better to have memorized. Now, if we go to point E, which is, so this is 0, a distance of 0, distance of pi/2. This will be a distance of pi/4. 1/8 of the way around the circle. 1/8 of the way around the circle, you notice that U and V are going to be equal to each other. This is a 45, 45, 90 triangle. So what are the coordinates? 0.707 along the U axis and 0.707 along up the V axis. That's where this point E is. We get that from 45, 45, 90 triangles. Another way to say that would be square root of 2/2, comma, square root of 2/2, as you can see right here. Now, if we know that information, over here we can say that we've got, if we know where E is, then we can also similarly say where H is and G and F, because they're just going to be mirror reflections over the V-axis or over the U-axis. So if this is square root of 2/2, if this is all positive, then both the coordinates over here are going to be negative. Negative U coordinate, negative V coordinate. And over here, we're just going to have the negative U coordinate and still keep the positive V coordinate. Here, we'll keep the positive U coordinate and make the V coordinate negative because you're going down. So all of a sudden, we've got 1, 2, 3, 4 locations that we can figure out because we knew 45, 45, 90 triangles. And remember, the square root of 2/2 is just going to keep on popping up over and over again. We can do the same thing with a 30, 60, 90 triangle. So 1/12 of the way around the circle, so like from the 3 o'clock position to the 2 o'clock position on a clock, we're going to go 1/12 of the way around a circle. That's pi/6, a distance of pi/6. And because this is a 30, 60, 90 triangle, we know that we can go over square root of 3, comma 2, and then up 1/2. You can even see visually right here, like halfway between this point. If this is 1 unit up and this is 0, from 0 to 1, halfway is right here. It literally is halfway in between these 2 points. That's how high up this is. It's made it the vertical distance is already half traveled when you go from here to here. This is square root of 3/2, and so therefore you can also reflect. You can make the V coordinate negative down here. You can make the U coordinate negative over here, and you can make them both negative right here. I think I have. So what I'd like you to do is tell me, where is the P coordinate? Where is the P dot? Oh, give me the U comma V, and that'll be for your Edpuzzle check. So now we know where these points actually are on the UV plane. And from yesterday, you can tell the different distances from point A. If we start at point A, then B is going to be a quarter circle. Where is it? B is right here. It's going to be a quarter circle times 2 pi is pi/2. C is going to be half a way around the circle times 2 pi is pi. D is going to be 3/4 of the way around the circle times 2 pi is equal to 3 pi/2. You can see here, we can figure out E, F, G, H. E is 1/8 of the way around. F is going to be 7/8 of the way around. Where is F? Here it is. F. G is going to be 6/8 of the way around. H is going to be 3/8 of the way around. You multiply all those by 2 pi to get their actual distances that the point travels as it goes around the circle. M, R, P, and N, those are all going to be on the clock. 1/12, 5/12, 7/12, 11/12. Multiply by 2 pi and you get these distances. Check it out. Some of these points, there are some other special points. Like if you want to confirm whether or not this particular point is on the unit circle, you can just plug it into the Pythagorean Theorem. A squared plus b squared equals c squared. Because all the points on the unit circle have got to satisfy a squared plus b squared equals c squared is equal to 1, and c is going to be equal to 1. So this is the u coordinate, v coordinate, and 1 squared. Do they check out? Yep, 25 over 25 does equal to 1. Find the coordinates of its reflections. So it's going to be 3/5 here. It's not going to be on any one of these special hash marks. I'm going to guess that 3/5 is like u is 3/5 here and 4/5 of the way up. That's where I think it is, more or less. I'm just sketching it. This has the point 3/5, 4/5, and if you reflect it, if you make the u coordinate negative, it's over here. If you make the v coordinate negative, it's down here. And if you make, oh, I'm sorry, I did that a little backwards. The point that they actually asked you to plot already had the v coordinate negative. So we start here, and then if you make the v coordinate positive, reflects up, reflect it over here, or change both signs, you'll get over here. Next is the point, oh my gosh, negative square root of 35 over 6, comma, negative 1/6. Is that on the unit circle? Let's find out. Plug them into a squared plus b squared equals 1 squared, and you can see we get 35, the square and the square root cancel. 35 over 36 is plus 1 over 36 is equal to 1. So yeah, it does work. And if you plot this point right here starts in the quadrant 3 where both coordinates are negative, and you can reflect them both up this way, or change both of their signs and get right here, kind of making this rectangle right here. So there it is. The video's over. That's what we got to do. I'd like you to copy your problem list to assignment 6A1 and do the first problem, and I'll see you in class.